So hello and welcome to this KBC Network's EMEA webinar. Hang on, let me just move my mic, that's better. Now you can probably hear me better. My name is Craig Kennedy and I am the Technical Solutions Architect for KBC EMEA region. We also have Janine Tucker in here, who's KBC Marketing, and Luis Angulo, who's Commercial. In this webinar, we're going to cover the KBC wireless solutions and we'll include a little bit more detail of the technical aspect than normal. So I hope you find it informative. You can post any questions in the chat window at any time during the webinar, and I'll try and get to them all at the end. So yeah, here we go. Just move my mouse. Okay. So COVID, still here, and still no signs of it going away anytime soon. I figured by now this would all be over, but sadly not. Some of us are still trying to figure out how to work from home, while others are returning to some semblance of normality, for the time being anyway. But even with everything that is going on, KBC are still producing, and our teams in the USA, UK, Dubai, Mexico, and China can still be contacted to help you at any time. Shipments from our USA and China facilities continue as normal, and there's still selective stock available in Spain. KBC Networks has been trading globally now for just over 25 years. During that time, we've won a few awards, including the SIA Best Network Support Solution, and more recently, the ASMAG Buyer's Choice Award for our ThroughLink hardware VPN and our eCopper IP over coax and UTP solutions. I apologize, I think I've skipped. Yeah, I've got a slide in the wrong place, but I apologize for that. I'm going to skip straight to the next one. That's my fault. KBC Networks have 6 main product lines. Our IP range, which includes our network switches, SFPs, and media converters. Then we have our in-house developed ThroughLink, a hardware VPN, our wireless solutions, our analog fiber optics, eCopper, which is our IP over coax and IP over UTP and twisted pair product, and finally, our remote power solutions. In this webinar, we're going to be covering the wireless, and as I said, we're going to go into a little bit more of the technical side around wireless transmission. And again, feel free to ask any questions, and we should be able to get to them all at the very end. So, we're going to jump right in at the deep end and start with the Fresnel zone. If you've had any involvement in wireless transmission outside of your standard home routers and office routers, then the chances are you'll have come across the Fresnel zone. You'll have heard about it. The Fresnel zone is the area both between and around a transmitter and a receiver. In the case of KBC, it's around our wireless transmission and the area between both ends of a link. In this very simple illustration, the stretched American football shape is the Fresnel zone. So this is the area we're talking about. As the signal leaves one end of the link, it can take many paths to get to the other end. These paths fall within the Fresnel zone and can be straight through, at the top, the bottom, the left, and the right, with variance in all of those different directions. Now, because the signal takes these different paths, they all arrive at a slightly different time. So we'll be slightly out of phase due to the different path lengths. Now, some of these signals will be combined, while others will be ignored. This is known as constructive or destructive interference. The constructive will merge with the other signals or just be ignored because they're not needed, while the destructive will be seen as interference and obviously will have a slightly negative impact on the receiving signal. How negative depends entirely on the level of interference. You can see here the trees are inside the Fresnel zone. So in this situation, the trees are causing what's known as signal reflection. Essentially, the signal that hits these trees is going to be reflected off at different angles and will more than likely become destructive interference to the signal. And the system in this example may actually work, but you will also find it might be unstable, there could be a heavy loss of signal, lower available throughputs. And if you asked me from a support point of view, because you were having problems, I would tell you you need to raise the antennas up higher to cover this Fresnel area. And lastly, one more consideration, which has come up several times. You have wireless installed and it all works perfect. You have a perfect signal, you have all the throughput you need, and then suddenly it's spring. And all those bare trees that had no leaves on suddenly have leaves that weren't there before, and they've grown in height, of course. So all these leaves that were not there before are now causing reflection issues, which you now have to deal with. So just remember to consider the environmental changes when installing wireless. Are there trees? Are they going to grow into that Fresnel zone? Is the construction going on? So that's the very basics of the Fresnel zone. There's a lot more to it than that, but we're not going to go to that much detail. But it is key to a working system, or a well-working system anyway. Now, the Fresnel calculation. At the bottom of the slide, you can see the actual formula used to calculate the Fresnel zone in both kilometers and meters, and miles and feet. There are thousands of online resources that can help you with that calculation, so you don't need to know the maths. But I thought it would be good to actually take you through the calculation process because it's not that complicated. If, like me, you're not a fan of formulas, this will maybe help you. So let's say we want to transmit 2 kilometers, and we're going to use the 5.2 gigahertz frequency. First, you need to multiply 5.2 by 4. This is because there are 4 Fresnel zones, and we need to calculate based only on the first one. Next, we divide the distance, so 2 kilometers, by the previous answer, which in this case was 20.8. Then you need to find the square root of that answer, which you can do on a calculator. In our example, it's 0.31. And then lastly, you multiply 0.31 by 17.32 if you want meters, or 72.5 if you want feet. This gives you the Fresnel radius, in our case 5.37 meters. That's the midpoint. So that's the largest part of that football shape. Needs to be at least 5.37 meters. The 17.32 and the 72.05 are created as a result of someone far smarter than me who's calculated the power output, the signal strength, curvature of the Earth, and the alignment of the stars, etc., to provide us with the number that we can use without having to make all of these power calculations each time. So think of it as an average almost. And there we have it. That's the Fresnel zone. The calculations are quite straightforward, but you do need to consider the Fresnel zone in any distance wireless system because it is something that will cause an issue if you don't consider it. Now, a free line of sight doesn't actually mean a free Fresnel zone. When we say line of sight...
Hey, Craig. Hi, it's Luis here. Hi, everybody. I believe one of the implications of the Fresnel zone, not only to have a clear line of sight, but also to assist everybody on how tall the pole to mount the wireless should actually be, because you got to respect the Fresnel zone. So that means that as farther as you go, the higher you have to put your wireless antenna up.
Yes, of course. I mean, there is a separate mathematical calculation you can use to work out the ground to the base of the Fresnel zone. I haven't gone into that in this, to be perfectly honest, but I can send it out to everybody once we've finished. Because this calculation for the Fresnel zone, let me go back, is basically to work out that bubble, essentially, how big it needs to be. Obviously, you need to take into account the ground level as well. In the example, we have the wireless antennas mounted to the corner of buildings. Now, okay, those trees are significantly higher than they would be in reality. But if it was a building, and we'll come on to some of that a bit later on, we would have to raise these antennas up on a pole on top of that roof. So yes, you have to take that into account. And distance does change, obviously, the Fresnel zone calculation itself.
Right. So the Fresnel zone gives you, if you know the diameter of or the radius of the Fresnel zone, you know that your antenna pole has to be higher, taller, yes, than the radius of the Fresnel zone.
Absolutely.
So that's the first thing. Sometimes we have customers talking to us to design the system, and they say, "Oh, I'm going to use a pole of 4 meters high," and we say, "Well, 4 meters high might not be enough.
No,
if you want to cover that distance, you know."
Yeah, especially over water, which I've come across as
Yeah.
well. So yeah, now these are all valid points. What I'll do is at the end of this, and when we send out all the information, we'll send out information on all the calculations involved, including how to work out the different heights. But essentially, if you know, as you said, Luis, if you know the actual size of the Fresnel zone, you can work out mathematically the pole needs to be 12 meters high, or it needs to be 3 meters on the top of a building. This is, I mean, we're trying to cover here as well, just the fact that a lot of people don't consider things like vegetation, which does grow, of course. So it might work now, but in 2 years' time, it won't work. So these are all things part of the consideration. So yes, the Fresnel zone, once you know that, you can calculate the height of the pole as well.
All right. Thank you, Craig.
Thank you. So as I was saying, a free line of sight doesn't mean a free Fresnel zone. When we say line of sight, we mean the Fresnel zone. And if your system has the edge of a building or a tree in the Fresnel zone, then we would say that isn't a clear line of sight. This doesn't always mean the system isn't going to work, but what it means is that you may have issues. And if you contact us and say, look, you've got a problem, yeah, there's a bit of a tree in the way, or there's a small part of a building in the way, we're going to say, well, that's part of your problem. To put it in another way, I'm going to use a car analogy. I'm hoping everyone's okay with car analogies. You've got a 6-cylinder engine, but you're only running on 5 cylinders. That's what the Fresnel zone works like. You know, if you lose one of those cylinders, or you lose a part of that Fresnel zone, you're not going to be using the system as optimally as it can work. And obviously you can see on the right-hand side here, we've got a few very basic examples. Line of sight, the Fresnel zone is clear, it's a good system. Obviously, if those trees grow any higher, it's going to become a non-good system, which is like the second and third examples. So just consider the Fresnel zone, it is important. If you can see the antenna, that doesn't necessarily mean the Fresnel zone is clear. And here we have a wireless link of 4 kilometers in distance. You can see that Fresnel zone is stretched, so the football is stretched. I can't remember what the calculation for this one is, to be perfectly honest. Probably in the region of about 8 to 9 meters. And you can see, if we look inside the Fresnel zone, so from the wireless transmitter's perspective, what you can see is you can see the end of the link, but you can also see the bits of buildings that are actually inside that Fresnel zone. So you need to raise this up to overcome those obstacles. Now, if that's not possible, you can't raise it up above the building, then you would need to use a relay. So set up 2 point-to-point links rather than just one, and go around the obstacles. So you can do that as well. So just try and keep the Fresnel zone as clear as possible. And if you can't, then expect signal loss, possible interference. Knowing what to expect is going to help you and us figure out how to fix the problem. So the more information you've got on the issues, the easier it is to fix. All KBC Networks wireless solutions are for IP transmission only. We have no analog transmission. We offer 3 primary frequency ranges: 5.1 gigahertz, 5.5, and 5.8. Each of these will only be usable in countries where they're allowed. So if you configure the unit with a European country, then only the European acceptable frequencies for that country are going to be available to use. Each country have their own specific usable frequencies. We don't determine that. When it comes to bandwidth, we keep it simple. 99 megabits per second or 650 megabits per second are the options. The WES3 is a 99 megabits per second unit, while the WES3 HTG and the EXP, which we'll come on to later, are 650 megabits. Apologize for the bus noise, by the way, I have my windows open. Both models are compatible with each other, only the available throughput is different. So if you link a 100 meg unit or a 99 meg unit to a 650 meg unit, essentially your limitation on that wireless link is the 100 meg or 99 meg, sorry. All of our wireless units are for use in harsh outdoor conditions and are IP66 rated. And we offer 4 different antenna options. The WES3 and the HTG units are available in a 5 and a 13 dBi omnidirectional antenna. Unlike a directional antenna, these offer a 360-degree area of coverage, but most have a shorter achievable distance of between 50 and 350 meters, so you have to take that into account. These types of antenna aren't used very often due to that distance limiting factor, but they do have a place in some systems. More commonly used is our standard fully integrated solution, which is available as a 9 dBi and a 17 dBi directional unit. The 9 dBi unit has a horizontal beam width of 65 degrees with a vertical beam width of 33 degrees, so it's perfect for point to multi-point systems. However, it does mean you don't go quite as far, so around 3 to 4 kilometers. again, with the Fresnel zone taken into consideration. If you've got a perfect scenario, perfect Fresnel zone, you may actually achieve a much further distance, but that's what we specify. While the 17 dBi has a horizontal beam width of 30 degrees with the same 33 degrees vertical beam width, sorry, that's like a tongue twister to me, but because the horizontal is narrower, it can actually achieve a greater distance of 5 to 6, sometimes 8 kilometers. We do have some systems operating at 8 kilometers without any issues at all. It all comes down to the line of sight and interference, so that Fresnel zone again. The beam width is less important. If you're looking for a point-to-point system, for example, the beam width is irrelevant because you're going in a straight line essentially. But when designing a system using a point-to-multipoint, you do need to consider the beam width and the angles, because this is going to give you the coverage you need. And obviously those multi-point clients are feeding into the same host. So it's just something to bear in mind. It is common when using a wireless point-to-point system that you use the 17 dBi antenna, and when you need to go further or around an obstacle, you can simply use a second point-to-point link and join them together. As long as you space them a meter apart, they'll be fine. I haven't tested how many hops you can have, but we know you can have quite a few. It's just a simple way of extending the system. Now, in the case of a point-to-multipoint system, where you have multiple remote clients all coming back to a single host unit, we're always going to suggest using the higher throughput WES3 HTG unit as the host point, and the standard 99 megabit units, the WES3, at each of those remote client locations. This will ensure you don't have any throughput issues when using multiple clients. If the system needs to expand, then you just need to add more hosts to that central part to take into the coverage that you need. But in reality, your only limitation is going to be throughput, and of course, your Fresnel zone, line of sight. And using both point-to-point and point-to-multipoint, you can create wireless networks over almost any terrain, going around difficult obstacles, and to transmit 5 kilometer plus distances when the line of sight is good, while at the same time, smaller wireless point-to-point and point-to-multipoint systems can be used to bring in other networks into that existing network. Think of it as a trunk. And don't forget, we do also have solar and wind turbine solutions. So if you need to put a wireless unit in a remote location and you have no power, we can provide you with that as well. In this very basic system design, and it is basic, I did this one, we have 3 remote locations. Each of those remote locations have multiple other locations. So what we did is we created 3 multi-point networks, which are the blue lines here, and then 3 point-to-point links to bring those multi-point networks back to the central location. Because we knew this network was going to expand, we're using the HTG as the point-to-point links and the standard WES3 units for the multi-point. So where you can see, get my pointer back up, just a second. Where you can see here, for example, you've got 3 remote devices. They're not that far apart. They might be a couple of 100 meters, maybe 300 meters away from the central point here. Here we have a 100 meg receiver or a host, and these are 100 meg clients or 99 meg clients. Sorry, it's easier to say 100 meg. And then we have also an HTG unit to bring all 3 of these back to this location where we have multiple HTG units to pull back all of these. So it's very simple to build the network up. And in this location where we've got 5 hosts, those hosts can be around the top of a building, just pointed in the general direction they need to work at. The distances here, the maximum distance here was around about 800 meters, so it wasn't that far. But it can go obviously a lot further. Again, it's all about the Fresnel zone. These are all very low houses, so there was no issue with height. And the buildings in the center are extremely high, so we had the coverage we needed. Let's get back to normal. So now we're going to go into, unless there's any questions, now we're going to go into a little bit more technical information, the wireless channel width, something else to consider. The width of the channel used is going to determine the throughput available over the links. Selecting to use 20 megahertz, for example, will allow the WES3 to offer 99 megabits per second throughput, while a channel width of 80 megahertz gives you the 650 megabits per second using the WES3 HTG. So the wider the channel width, the more throughput the link has. The downside to the higher channel widths, of course, is that they're more susceptible to interference from outside sources. Remember, these same frequencies are being used by other systems, not just KBC. So using an 80 megahertz channel width means you get interference from up to 16 different channels, potentially more depending on what the other equipment supports. Beam widths, for example, of 5 megahertz are often used on other equipment. So that can mean up to 40 channels causing interference with your system because they're all within that 80 megahertz channel. That's why we always suggest a site survey when possible. Now, a site survey is basically checking the immediate area where you're going to install the wireless, and if you can, the area between, for any potential signals that are going to clash with your frequencies. It also lets you work out if there are frequencies there that are being used, you can work outside of those frequencies and use one that's not being used. It lets you find a good frequency. There are many apps available on Android, probably Apple phones. I'm not an Apple phone guy, so I don't know. On Android, there are lots of apps you can use that will do a site survey for you. They even check against frequencies that we don't support, but they will allow you to find a channel that's open and free, that's not being used by anything else. However, don't select the 80 megahertz if you don't actually need it. Using the wider channel width when you need 20 megabits per second, it's only going to mean more opportunity for interference in the first place. So if you need 20 megabits, use the 20 megahertz. It works fine and it will give you 99 megabits. If you need 80 megabits, use the 20 megahertz. Again, you're still going to get that coverage you need. So don't go big just because you can. You don't necessarily need to. It's no different to having 3 computers on a network. Instead of using a typical 192 address, you go all out and use a full Class A network. You don't need to. Just a consideration, that's all. Something that's rarely taken advantage of when using...
Greg?
Yeah.
The new frequency, the 6 gigahertz frequency, yep, has been already approved by North America, US.
Okay.
I'm not sure if this is going to migrate to the EMEA region in the future, but that frequency has been approved, and now the channel width for the 6 gigahertz goes up to 160 megahertz.
Okay, so that's going to mean significant, that's going to mean gigabit wireless Ethernet, basically.
Exactly. So what it means is that the new frequency approved in the US is going to be allow us to communicate in a much higher throughputs and even do applications such as backhauls and things of that nature as well. It's just a side note for our friends that are attending, as new information that was just signed 30 days ago.
Great. Well, chances are we will probably have that at some point in the future. I can't say when, but I'm pretty sure we will have that frequency available to us, and our systems will support it.
And then we, as we move into legal things in the region for EMEA, most likely KBC will be providing a new product to offer such a larger channel width to the customers. Okay.
Yeah. Although, and that's great when you need that backhaul throughput. Just bear in mind, if you're doing a simple point-to-point or a simple multi-point system, and you only need 20 or 30 megabits, don't go over the top if you don't need to. That's all I'm trying to clear on this one. The higher throughput stuff is going to be exciting when we have that one. It's going to be interesting.
Yeah, good point.
So something that is, as I said, rarely taken advantage of when using the KBC wireless, and something you may not know if you've used our wireless before, you might not have even realized this, is that the antennas themselves can be on an entirely different network to the rest of the equipment connected. So in this rather cluttered system, you can see here, we have 5 remote sites with remote cameras, computers, access control, BMS, MVRs, DVRs, telephone system. There's probably an IP coffee machine somewhere in here, all of which are IP based, and all are on a single subnet, 192.168.1. whatever. But the wireless units are all using an entirely different subnet, 172.16.1, or you can have any subnet you want. This feature allows you to build your bridge network and link up all your sites as a single subnet. Anyone on the network sees only the devices on the network. They won't see or be able to access the wireless units. The goal of the wireless link is just to get the information from one or more sites to the other. So the IP on the wireless units is essentially only used for you to gain access to the configuration and make changes. It's very simple. And we use the name host or access point, or AP, and client to determine the function of our wireless unit. So if you see a unit that's with host written on the back, it's a host unit. And the host essentially sit there waiting for the clients to connect, although it is two-way communication, obviously. Typically, the host is located at the central point, which you can see here, or the control room, and the clients are usually out in the remote locations. But it is worth noting, on a point-to-point system, it actually doesn't matter which way around the host or client go. It really doesn't matter. As long as one is a host and one is a client, the system's going to be fine because it's point-to-point. And lastly, we have the WES3 HTG EXP, which is a right mouthful, which is our high throughput unit in an explosion-proof enclosure. So the WES3 HTG EXP meets explosion-proof class 1 and 2, division 1 and group B, C, D, E, F, and G. It's also available as a 9 and a 17 dBi, and of course it can communicate with our standard WES and WES HTG units as well. So this can work and be inside an area like a gas, oil, petrochemical site, for example, where there might be explosive gases, communicating outside of that area to a standard HTG or a standard WES unit that's not in an environment that needs to be explosive proof. And just for those who aren't sure what explosion proof means, it doesn't mean you can't blow it up. We've had that discussion a few times. It means it won't cause an explosion. So nothing from this will create that catalyst, for want of a better description. So now on to a real system. I'm only using one example in this whole presentation. It's an interesting one. We have a mobile championship go-karting system. I'm sure you've all come across go-karting. In the UK, there are 35 championship tracks, but only a few of them actually have any trackside security. So anyone that wants to jump onto that track, there's no way for them to know in advance. So a deployable system was created using portable masts that can be raised and lowered as they need to. You can see a picture of one on the right-hand side here. We didn't do these masts, by the way. This was the actual integrator that did this. Each one of the masts holds 2 high-speed PTZ dome cameras, which are PoE++, and a WES3 99 megabits per second unit, which you can just see on the right image as well. Then inside the enclosure at the base, there's a large black box you can see there at the bottom of the picture. That's got an 80 amp hour battery in it with a 12 volt to 48 volt DC power converter, which essentially provides power to one of our PoE++ switches, which in turn provides the PoE power required for the cameras and for the wireless client. Now, each of these systems are deployed wherever they're needed, and the WES3 is simply pointed towards a 13 dBi omnidirectional host located at the central point. Now, obviously, the track size, this looks quite large, but this is one of the larger tracks. The biggest size, distance-wise, is about 650 meters, so just under half a kilometer. The 13 dBi omnidirectional antenna is basically sucking in that signal. So all of these deployable units, those red arrows on the left-hand image represent more. You can just make some of those out. They're a bit small. Are basically pointing at the same host. So this is a multi-point system. Each one of those deployable systems, of which there are 12, are all pointed at the same one host. So none of these are point-to-point. It's an entirely point-to-multi-point system. But it allows the client to place the cameras anywhere on or off the track, as long as they've got a good line of sight, good Fresnel zone, for example, then they're fine. And these distances are so short, the Fresnel zone is a meter and a half maximum, which means they're high enough. And go-karts, of course, are not that tall. And the exact same system can actually be deployed on a beach, an open air event, public parks, temporary car parking, anywhere needed. Add a solar panel, and you can extend the actual time the system remains operational for even further. So it's a really good, simple solution that we think they're going to be expanding on. I don't know why that black slide was there, so I apologize for that. All KBC wireless solutions are configurable using a built-in web GUI, which can be accessed from anywhere within the wireless network. On the back of the unit, along with the power and Ethernet activity LEDs, there are 4 RSSI indicator LEDs. These give an indication of the connection quality in dBi. And once connected, you can MAC address lock the whole client and host together, so when that client powers down and back up again, in the case of the go-kart system, for example, it automatically knows where the host is, how to connect to it, and it connects. This is pretty handy in a multi-point scenario where you need to specify specifically which host, which client can talk to, because you don't want the client searching for one and just connecting to anyone. As well as 128-bit encryption on the link, you can also hide the SSID from being seen, just for added security. And remember, to make your life easier, if you need a point-to-point link, you can order pre-locked kits. So you can buy a point-to-point link that's pre-configured, you put it up, you plug it in, and your system's going to work straight away. So you don't have to do anything. And if it's a more complex system with multi-point or multiple point-to-points, for a small fee, the factory will actually configure the whole system for you, labeling everything up to make it easier for you to install. Again, all your engineer has to do is mount it, plug it in, and point it. The units are robust and simple. The only thing that's going to cause any issues is line of sight and interference. Remember, the Fresnel zone and signal interference, both of which are the same for any wireless solution you look at. We use the unlicensed 5 GHz, soon to be 6 GHz frequencies, and meet all of these that I'm not going to read out, IEEE standards, which I'm not going to read, as well as supporting the previously mentioned frequency ranges of 5180 to 5825. The units are configurable as host or client, and point-to-point or multi-point, so it's entirely up to you which is a host and which is a client, and the topology of the system, and you can change it around as you need to. So if you need to make a client a host, you can make it a host later on, it's not a problem. Depending on the country, we support up to 30 dBm transmission power. Now the power levels are actually dictated by the country of usage. Every country has their own rules. So when you select the country of use, the power level available is going to rise or fall depending on the country rules. All wireless nodes support 128-bit AES and TKIP encryption ciphers. And powering the units can be done using a power input module or from an alternate PoE source, a PoE switch, for example. Now, the WES3HTG can be powered from either a 48-volt DC power input module, so just a standard PIM, or from a PoE source, another switch. But the WES3 is available as PoE or with a power input module, but you can't power a power input module version from a PoE source. Just bear that in mind. So you need to make sure if you need PoE, order the PoE version. If you're not sure which one it is, contact us and we'll tell you. It's not a problem. All of the units are, of course, IP66 rated for outdoor use in all weather conditions, and we do have them in extreme hot and cold environments, as well as coastlines with no issues. And the mounting brackets provided are extremely rugged in design. There are no plastic pieces and no cable ties to attach things. And I know you all know what I'm talking about when I say cable ties to pole mount these. We don't have that. You get everything needed to mount these on a pole or mount them on a wall. You don't have to worry about the mounting kit. It's not separate, it's part of the package. At KBC, we're always going to do our best to ensure you have the solution you need, but we're also going to try and simplify it as much as possible by suggesting the use of other systems to complement or further that solution. The SPB is one of these products. It's a small power box which takes a mains power source in, 110 to 240 volts AC, and allows you to redistribute that mains power in the form of 12 to 56 volts DC, PoE Plus or PoE++ devices. Essentially, the SPB simplifies the power requirements of remote locations where there's often a need to have 2 or more different power types, but you've only got mains power and you don't want to have to go down the route of having plugs and sockets everywhere. 24 volts DC and PoE, for example, in one location. The power boxes can be ordered with your specific requirements, including the addition of any switches you need as well. So all you need to do is connect the mains power, mount the box, and you're good to go. And this is an outdoor box. This is designed for all weather conditions. It's entirely waterproof. And then for those situations where you might need a deployable transmission system and you need power, we have several options, including a fully integrated solar power kit, which offers the panel, controller, batteries, and the enclosure, a complete turnkey solution. So wireless, it gives you the alternative to the civil engineering costs of digging up the roads or trenching, I think is the other phrase I've heard, to install cabling or fiber. It's simple, it's cost effective, and as long as you have a good line of sight with little interference as possible, the system can offer stability for any network. It also offers the option to bring in smaller other parts of a network into a larger network without adding any complications regarding configuration and networking. And just in case you need to, we can take that wireless signal and feed the entire network into a fiber backbone, providing the media converters for it. And we do have systems where they use wireless and our fiber optic media converters as part of the same network. And of course, we have our e-copper. So if you've got an old coax system or maybe a twisted pair system that needs to be transmitted a longer distance, you can put it onto wireless. Keep using the existing cabling, convert the whole system to IP using our e-copper, and then throw it onto our wireless network to give you the distance. Really simple solutions. Just briefly on our warranty terms, 5 years for fiber optics products and industrial switches, of course. We have different warranties for different ranges. For e-copper, media converters, it's 3 years, and 2 years for our ThruLink and wireless. But again, we have thousands of these devices installed all over the world, running for a lot longer than these periods. The solar, it's a bit different. We guarantee delivery of at least 90% of the capacity for 12 years. KBC have a very good reputation for giving fast, high levels of support, I hope. There's a few of you in here I know that I've supported in the past, often going over and above the standard support expectations. We will always do our best to respond as quickly as possible. We're always on hand to assist and with product selection, guidance, system design, and product support. Most of you in here already have my contact details, and some of you know me quite well. You can send an email to EMEA@kbcnetworks.com with any questions you have, doesn't matter what they are, or contact me directly as well if you've got my details. Like I said, we're always there for support.